Okay, so we're going to run a corrosion experiment on tungsten carbide. First thing we do is we log into the computer. After you've logged into the computer, you're going to click on EC Lab here, and you're going to open up the software. All right. Then you need to make sure that the software is connected to the potentiostat. In the back there, on the back side, there's a back in the back here. There's a power switch. You got to make sure that power switch is on, and then after that's on, you have to go into this little thing here, add devices. We add a device like this. It's the one that should be recognized. We select, and then after we do that, it's going to say, it's going to do something like this, and we should be connected. All right, excellent. So then we're going to prep our cell. All right. To prep the cell, we're going to get some of our tungsten carbide electrodes ready here. We're going to get our 100 millimolar potassium nitrate, okay, or whatever solvent you're going to be using. The solvent will probably be kept down here in this drawer right in here. So right there. All right. So we're going to get our electrode, our nitrate. We're going to get our reference electrode. So we have our reference electrode here. Actually, the reference electrode that we're using is right here. It's kept in this little blue rack right here, in there. See how it's stored? Just like that. We don't want this to tip over and get the salt water solution. This is a concentrated solution of potassium chloride onto this electrode piece right there. So we keep it standing straight up and down like that. Okay, so we have our reference electrode, we have our working electrode, and then we'll find our counter electrode, which is going to be a piece of this platinum material here. All right, we have a couple pieces of platinum material, one that's going to be a little connector to the working electrode, and one that's going to be the counter electrode itself. Okay. The other thing we need to get is a beaker. So we'll start with probably this size beaker here. Okay, this size beaker here. I don't think this clamp is going to be able to hold this beaker here, so that's all right. We don't need to have a clamp, but it's nice to have a clamp to make things stable. All right, so we have our this box here has our clamps in it. All right, we have our blue working or counter electrode. It says right there CE, counter electrode. Our red WE, working electrode, and this white one is the reference electrode. We'll take the alligator clips. Use the same colors, doesn't really matter, but it's consistent. Put on the red, put on the white, put on the blue. Okay. Our counter electrode, like I said, right here, the blue one, will be this platinum piece right there. All right. Our working electrode is going to be connected to the clamp through the platinum piece like that. We're going to connect this one to there with a magnet. The magnet should be in here. This is an example of the magnet. This wouldn't need to be the exact magnet we use, but this one should be fine. See how it makes a nice good seal like that? So we're going to clamp this onto the electrode there, and then use this magnet to get a good seal there. This cable right here can rest on top of this right here, and that way we can get it to be as long as we want. So we have the working electrode there. We're going to set the working electrode down onto the bottom right there. That's good. Oh yes, that magnet can also help us hold it in place by being magnetic to the bottom, which is good. Okay, we're going to move that reference electrode all the way to one side. All right. Sorry, the working electrode. So it's pushed all the way up against one side here. And then the reference electrode, I'll use these tweezers here to pull it out. I mean, you don't need to, but you don't want to spill that solution there. That's a nice solution we want to keep. We don't want to have it spilling to the side. This is our reference electrode. Okay. We'll clamp the reference electrode on like that, and that can be poised in a place. So let's see if we can get this thing to. There we go. If we put the reference electrode kind of touching right up against there like that to the working electrode, keep those nice and close like that. Okay. And then the counter electrode, it's going to come down and try to be at the opposite side. Just like that is fine. So the distance is important. It's important to have the electrodes in the same place every time. So this, again, the working electrode, the piece of tungsten carbide is going to go all the way flat like that. The counter electrode is going to be opposite like that, as far away as we can get it. We can use this to kind of help us push it into the right spot, but it was fine. So that's, oops, that's good right there. Okay, and then the reference electrode kind of up against the working electrode. All right, now we're going to run a run here. I'm going to show you the setup, the experiment that we are going to be running. All right, this we can minimize. It's down here if we want it. The experiment that we're going to run, new, we're going to, oh yes, we need to be in modified mode, so we just say yes there. Electrochemical techniques, voltammetric, chronoamperometry. Okay, double click on that one, and it's going to say what voltage do you want to apply versus and we want versus the open circuit. Well, actually what we'll do is versus the reference. We'll do versus the reference. Okay, and we're going to have a voltage. I'm going to put in here, whoops, 2 volts. All right, we're going to go for 5 minutes. This is hours, this is minutes, this is seconds. 0 seconds. All right, I'm not ready to start, but this is all set and should be okay, just like it is. All right, actually we're going to change this to record every 2 seconds. That's good. 2 volts, 5 minutes, record every 2 seconds, 2 volts versus the reference electrode. So this is ready to go, and when I push this, it's going to give me an option to name the file, and then it'll start the run. Okay, but before I do that, I need to find out the mass of my reference electrode. So I'm going to pull, sorry, my working electrode. So I'm going to pull these out. I don't want to damage the what's it called? I don't want to damage the platinum connector that I have there. So you got to make sure you pull gently here. But we need to get the mass of this material here, the mass of this thing. I'm going to give it a quick rinse with a little bit of alcohol. Alcohol, because alcohol evaporates fast. Water's not bad, it's okay too. So I could use water here, but I'll just use alcohol. So we got some here. All right. Okay, that's good. And then I'm going to go get its mass. Push pause. Right in the middle. Okay. Now I'm going to want to make sure I record this mass in my spreadsheet. All right. So 17.7920. We'll jot that down here for now. $17.7921. So we have the initial mass. Okay. Okay, so I have the mass of the electrode, I have the cell all set up again. Again, the working electrode is as far away as possible from the counter electrode, and the reference electrode snug up against the working electrode. I've added 30 milliliters of my solvent, my electrolyte, we call it. In this case, I'm using the 0.1 molar potassium nitrate. I want to turn on my bubbler here. Did I pop something? That didn't sound good. Push pause. All right, so I got my bubbler going. Gonna have a constant supply of oxygen there, so that doesn't limit our corrosion for any reason, okay? And I have 30 milliliters. It takes about 30 milliliters to cover the working electrode. I make sure the reference and the counter are all in. Make sure none of the clips, the actual clamps themselves are touching. And then I go back here and I can push start, say okay, and then I'm going to save it somewhere where I always start with the date of the experiment, 2024, all right? And then I can call this test, I can call this actually 2 volts, 0.1 molar, I can't use the point underscore molar, potassium nitrate. Okay, and then I push save, all right? And then when I do that, I should be able to look down here and, okay, hold on, push pause. Okay, so 2 volts was too high, so I lowered it back down to 1 volt here, and I'm watching the current that results after 1 volt, while 1 volt is applied for 5 minutes, okay? So I'm applying 1 volt. Looking down here at the electrode, let's see what we can see. You can see we got lots of bubbles appearing over on the counter electrode side. And on the other side, hopefully the reference electrode or the working electrode, we're going to begin to see some corrosion occurring there. All right, pause. All right, so you can see the solution has turned blue because the cobalt ion has leached out of the electrode here into the solution. All right, I turned off the bubbler just now before we started the video. Okay, so now I'm going to take that surface, that electrode, the working electrode, the tungsten carbide, and I'm going to go reweigh it. Okay, so I removed the tungsten carbide piece. I rinsed it off really well with water. DI water is fine. I dried it really well. If you want to do it with alcohol, if you're concerned that it's not drying well, you can do that as well. And then I reweighed it, and we have a mass of 17.7860. So we see after 5 minutes at 1 volt, you get that change in mass. So again, you're going to want to make sure you record these into your 17.7860. Okay, and then I'm going to put this back on and repeat it the exact same thing for another 5 minutes. All right, and then I'm going to do that 5 times and record the mass each time, putting it back exactly the same way. And then after I'm done at 1 volt, I'm going to go down to 0.9 volts. And then I'm going to do the exact same thing. And then we'll go down to 0.8 volts, 0.7 volts, 0.6, and we'll work our way down. And we're going to see the different mass changes for these in water. After we do that in water, then we're going to start doing that in our ionic liquids and see if we get some differences. Okay, great. Hopefully you can do the experiment now.